Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for finding maximum number of points on a line. Let's look at the problem description. We are given an array of points where points of I is x comma y represents a point in the xy plane. And we have to return the maximum number of points that lie on the same straight line. Let's take a look at the example 1. So in this, the number of points given is 3. And if you look at it, all the points are lying on the same straight line 1 comma 1 2 comma 2 3 comma 3. So that's why the output is 3. And in the case of example 2, we are given 6 points. Out of 6, these 4 points lie on the straight line, these 2 are not. That's why the output is 4. The constraints for this problem are the length of the points arrays ranging from 1 to 300, and the individual elements length is 2, and the value of x and y is ranging from minus 10,000 to positive 10,000, and all the points are unique. Let's look at the approach to solve this problem. So we are given the points array with 4 points, and out of this 4, these 3 points lie on the same straight line. That's why the output is 3. How can we find points are lying on the same straight line? If you look at this straight line, it contains 3 points. Okay. How do we find whether the next point extend this line as a straight line? For example, the next point may be 3 comma 1. In that case, it will not be straight line, it's kind of bended, right? So how can we verify that this point is extending this line as a straight line? If you observe carefully, the angle between the line formed by these 2 points and the x-axis is same as the angle between the line formed by this point and the x-axis are same. Okay, let's see here. So the point 2 comma 3 and 3 comma 2, the angle between this line and the x-axis is this. Similarly, when we extend that line to 4 comma 1, and if you compute the angle between this line and the x-axis is also same. So whenever we extend a line by adding another point, we compute the angle between that new line and the x-axis. Okay, and if that angle is same as the previous line, then we can include this point in the list of points that lie on the straight line. Okay, basically we can use the count map data structure. So whenever we add a point to create a line, immediately we compute the angle between that line and the x-axis. Okay, and then we check whether there is an entry in the count map. If there is one already, then we increment the count. Otherwise, we initialize this to 1 and then increment 1. Basically, at least there will be 2 points in the line. That's why the default value for this count map will be at least 2 if there is line. Basically, the line contains at least 2 points, right? That's why the minimum value for each entry will be 2 in the count map. Okay, so basically we have to form a line between each point with every other point. For example, 1 comma 1 to 3 comma 2, 1 comma 1 to 4 comma 1, 1 comma 1 to 2 comma 3. And for each line we compute the angle. In mathematics, that angle is called a tan 2 value. Next, we form a line with 3 comma 2 as the first point and then 1 comma 1 as the second. and then 3 comma 2 and 4 comma 1, 3 comma 2, 2 comma 3. So basically we form a line and then we compute the angle and then we keep track of the maximum count we have computed so far in this count map, and finally return that maximum count as the max point count for this input. So that's what I have written here. First we initialize the variable n and the max point count. The n is initialized with the number of elements in the input array. Okay. Then we traverse the points list, and in each iteration we initialize the first point and then the count map data structure. Then traverse the points list again to pick up the second point to form a line. So first we initialize the second point, and then if we check whether both first point and second point are same, only if they are not same, then we compute the a tan 2 value for the line formed by first point and the second point. Then we increment the count in the count map data structure for the computed a tan 2 value. Okay, and then we check whether the count is greater than the so far seen maximum point count. In that case we update the max point count variable, and then finally we return the max point count as the output. Let's look at the flowchart. The input for this procedure is points array. First we initialize the variable n and the max point count. So first the n is initialized with the number of elements in the input array points, and then the max point count is initialized with value 1. First we check whether the number of elements in the input array is 1. If that is true, then we return n as the max point count. Otherwise we initialize the max point count because there are more than 1 points, so we can form at least one straight line with 2 points. So that's why first we initialize the max point count with 2, and then we initialize the index I to 0. Then the outer loop starts. So each iteration we initialize the first point with an element point present at index I in the input array, and then we initialize the count map data structure. Then the inner loop starts. Here we check whether the index is less than n. If that is true, then we pick up the second point to form the line. Okay, the second point is located at index j in the input array. Next we check whether both first and second points are same. If they are not same, then we compute the a tan 2 value for the line formed by first and second point, and then assign that result to the a tan val variable. Then we increment the count in the entry associated with the a tan val in the count map data structure. Okay. Next we check whether the count for the a tan val is greater than the max point count computed so far. If that is true, then we update the max point count. Otherwise we go ahead and process the next point. We repeat this until we pick up all the points in the array as the second point, and then once that is done, then we go ahead and process the next point. We repeat this until we process all the n points in the array. Once that is done, we come out and return the max point count variable's value as the output. Let's move on to coding. First I define a constant x and y to read the x and y axis value in the point. Next I initialize the variable n with the length of the array, points array, and then I check whether n is equal to 1. In that case I return the value n as the output. Otherwise I initialize the max point count variable with value 2. Next I write the outer for loop. This will perform n iteration, and then each iteration I pick up the first point that is located at index I. in the input array. Next, I initialize the count map data structure, which is a map of float to int. Next, I write the outer for loop. Each iteration I pick up the second point in the input array to form a straight line. So first I initialize the second point variable with a value located at index j in the input array. Next I check whether the first and second point are same. If they are not same, then I go ahead and compute the a_tan2 value. I'm passing the difference between the y-axis value in the second point and the first point, and the difference between the x-axis value in the second point and the first point. Next I check whether there is an entry for the a_tan value in the count map data structure. If there is no entry, then I initialize the count with 1 for that entry. Then I increment the count. Next I check whether the computed count is greater than the max point count. In that case, I update the max point count. Then finally I return the max point count variable's value as the output. Next I'm going to run the test cases. Oops, compilation error. Okay, let me rerun the test case. All the tests passed. Next I'm going to submit this program. Cool, this program is accepted. Next I'm going to do the code walkthrough with sample input. We are given the points array with 4 elements, and among the 4 points only 3 of them are lying on the same line, straight line. So that's why the expected output is 3. So first we initialize the variable n with the number of elements in the input array. In this case it is initialized with 4, and then we check whether n is equal to 1. In this case it is false, so we go ahead and initialize the max point count with value 2, and then we enter the outer for loop, and each iteration we pick up the first point located at index I. Okay, I directly go to the iteration 1 because the iteration 1 will yield the expected output. So in the iteration 1, the first point is initialized with the point at index 1. In this case it is 3, 2. Okay, then the count map data structure is initialized with empty map of float to int. Okay, then we enter the inner for loop. In the iteration 0, we pick up the second point, which is located at index 0, that is 1, 1. Then we check whether I is not equal to j. In this case it is true, so we go ahead and compute the a_tan2 value between the point 1, 1 and 3, 2. And because there are no a_tan2 value already, so we create a new entry with the value 1, and then we increment the count. Okay, so this is to account the first point in the line. Okay, next we check whether the recently computed count is greater than the max point count. In this case both are same, so the max point count remains And in the next iteration, the j is equal to 1. In this case, both the first point and the second point are same, so we skip this iteration. Then in the iteration 2, we pick up the point at index 2 and compute the a tan 2 value between this point and this point. So the new a tan 2 value is different than the one we previously computed. In this case, we added a new entry in the count map data structure. Okay. Again, we initialize the entry with value 1 and then we increment the count. So it is initialized, it is set with count 2. Okay. And again we check whether the recently computed value is count is greater than the max point count. In this case both are same, so the max point count remains 2. And in the third iteration we pick up the element in the point at index 3. Okay, so we compute the a tan 2 value between 3 comma 2 and 2 comma 3. Okay, so when we compute the a tan 2 value, there is an entry already exists in the count map. So in that case we increment the count. So the count is changed from 2 to 3. Okay, so next we check whether the recently computed count is greater than the max point count. In this case it is true, so we assign the recently computed count to max point count, so which is 3, that is assigned to max point count. And finally we return that value as the output, that is an expected output. Next I'm going to do the time and space complexity analysis for this solution. The time complexity of this procedure is order of n square because we are forming a line between a point with every other point in the input array. Okay, for example in this case there are 3 points, so this for loop performs 3 by 3 iterations. If there are n points, this for loop performs n by n iteration. That's why the time complexity is order of n square. Space complexity is order of n because we are using the count map data structures to store the a tan 2 values and the count. So in the worst case there will be n entries in the count map. That's why the space complexity is order of n. Thanks for watching this video. Have a great day.